Today's video is about AWS Lambda. Lambda lets you run code without thinking about servers. Our video is going to be pretty practical. We'll go over the different options to configure a Lambda function. We'll see how to deploy it and get familiar with all the terms like versions, aliases, and triggers. Let's get started by creating our first function. There are a few options to create a function. We can either start one from scratch, use a blueprint, or browse a repository. We'll just start a blank one. We'll call it Lambda example. We'll use node 10.x, and as far as permissions, we'll let AWS to create a new role for us. In the previous video, we went over AWS IAM, Identity and Access Management, and saw what roles are and how do they work with permissions. So if you'd like to learn more about roles, you can check out that video. Now that our Lambda was successfully created, let's look at the different configuration options we have. First, we have these two tabs, configurations or monitoring. The main part of our configuration is the actual function code, and there's an editor in which we can edit this code. We have an option to configure environment variables. We'll take a look at that and we'll try it out. There are basic settings like choosing a memory and a timeout. We'll discuss that as well. And there's also a section to configure concurrency. We'll take a look at how this concurrency setting works. There's also a tab for monitoring. And under monitoring, AWS lets us see different metrics for a Lambda function like invocations, duration, and etc. And there's also a log of recent invocations and most expensive invocations for our Lambda function. We'll take a look at that as well. There are also these options on top. So under actions, we have an option to publish a new version. We'll see what is that. Create an alias, and we'll discuss versions and aliases as well. Under qualifiers, we have a list of our versions for our function and the aliases. And there's an option to throttle our function. We'll also discuss what that means. But before everything, let's get started with the actual code of our function. As you can see, we have this editor here, but we also have the option to upload a zip file with our bundle, or give Lambda a path to an S3 file which contains the code. So in here we can just put the link and Lambda will load the code from this URL. For our example, we'll just edit the code inline, but of course in production and when you're working and deploying a lot, it makes much more sense to write a script that will bundle everything for you and upload a zip file. In one of the previous videos, we went over and saw how to create such a script, and I'll link to this video below. And here we have this very simple Lambda function that just returns an object as a response and also has a single parameter event. We can edit this function, and every time our function will be called, this callback will be executed. One of the nice things about Lambda is it makes logging very easy. If we want to log something, we can just log it to the console. Lambda will automatically log it to the AWS CloudWatch logs. So let's try it out. Let's try to log the event object to the console and see what it contains. So now that we changed the function, we will save it and we will run it using test. First time we try to run the test event, we'll have the option to configure it. Lambda gives us this simple template of an object that has 3 attributes. So we'll just use this object. We'll call it simple test. So this object will be passed to our Lambda function as the event object. If everything works correctly, our function should log this object to the console. We'll create our test event and then we'll run it. After the execution was completed, we have the results right in here. First, it shows us the object that we got as a response of our Lambda function. And since we returned the response with a status code and a body, this is what we see here. Then for every Lambda request, we have a request ID. Using this ID, we can filter our logs and find all the relevant rows that were created by our Lambda function. Besides that, we can see which duration we were built for. So we were built for 200 milliseconds, and the actual execution of our function was 159 milliseconds. Also, we configured the memory of 128 megabytes, and we used a max of 75 megabytes. And at the bottom, we have the log output. So this is the rows that are relevant to the execution of our Lambda function. These rows were also written to the general log of this function that goes to CloudWatch. In that log, we have all the executions of our function And again, we can filter them by this request ID because every row that we log has the request ID in it. The first row is the start time and which version we run. Currently, the version we run is always the latest one. Then we have the row that we asked Lambda to log to the console. This row contains our event object. This is the object we configured when we created our test event with the 3 attributes. And since we logged it to the console, we can see it right here with the info tag. Then we have the end of the request and a report about our request and its usage. These are all the metrics that we saw above: the duration, build duration, memory size, and max memory used. So this was a single execution of our function. Now in this code editor, we can edit the contents of our function. But what happens if we add code in here? Let's log something to the console to see if it appears. Also, let's create a variable. We'll create a counter and we'll call it outer and set it to 0. Then inside the function, let's create another variable. We'll call it inner and set it to 0 as well. And then every time our function runs, let's increment both outer and inner. Then also let's log both of them to the console. Again, let's save our function and test it. In the results, you can see that we didn't get the row that we logged to the console in here, but we got a value of 1 both to the inner and the outer variables. Now let's try to run this function several more times. As you can see, the outer variable keeps incrementing, but the inner variable stays the same. And that means that somehow our outer variable is saved in between executions of our function. So let's try to figure out what's going on here. First of all, this statement was not shown because it was not part of our execution. Our execution is considered only after the function starts and until it returns a response. But the other interesting thing is that our Lambda function is supposed to be stateless, but somehow it does keep state between requests. So it somehow does know about this outer variable. And the reason for that is because the way Lambda works is AWS will start an instance of this Lambda function and it will keep running. And then every request that this Lambda function receives will be handled. So even though the function is supposed to be stateless, it does preserve some state. However, we can't rely on it because every time we save and run the function again, you can see that these values were reset to 1 again. So every time we upload a new function, it resets. Also, if you won't use the function for a while, AWS will also stop the process and it will lose the state of the outer variable. Also, when there are a lot of requests simultaneously to our function, AWS will start many different other processes of our function that will also serve requests. And these processes will have their own state. So we can never rely on the state of their Lambda function, even though it is a long-running process. The main point is that AWS can at any point stop this instance of the function and start new services, so you cannot rely on the fact that it's the same process. But if you're using something like a MySQL server, this would be a good place to create a connection to the server. If you create a connection here, all of our requests will be able to at least reuse the same connections to MySQL. If we'll configure it within the handler function, then MySQL will have to create a new connection for every function execution. But if we'll do it in here, at least we can reuse the connections for the process as long as it's running. Next, let's look at environment variables. Right under the editor, we have the option to configure environment variables. Let's say we need to use some third-party service, and the service gives us a token and a secret. So instead of hard-coding this token into our code, we can create a variable here. Let's call it secret token. And here we can input the value of our secret. There's also an option to encrypt it. So even when we store it in here, instead of storing the actual value, we can store the encrypted value and then decrypt it within our code. But for our example, we just use plain text. Now, when we run our function, let's try to log to the console this variable. So this variable automatically becomes an attribute of the process.env variable. So now if we'll save and run our function, we should see our secret token in the output of our log. And we can see it right here. We already mentioned that if we'll have a lot of requests simultaneously to our Lambda function, then AWS will start more instances of this function to handle all the requests. And that's why there is a concurrency configuration at the bottom of the configuration page. The value of our concurrency is currently set to 1000. This is the maximum value that AWS gives to every account, and this value has to be shared between all the functions in that account. If we'll set the value to 500, it means that all of our other functions will have to share the remaining 500. Actually, they'll have to share 400 because 100 always have to remain available. You can always ask AWS to increase this limit. When we set the concurrency to 500, it means that we allow AWS to start up to 500 processes of our Lambda function running simultaneously. If we'll set it only to 1, then our Lambda function will handle as many requests as it can, and for all other requests that it cannot handle, it will return an error. We can also set this value to 0. And when we do that, it effectively disables our Lambda function because it means that there is no processes of it running. If we'll save it, it immediately shows us this message that says that your function is always throttled. So in practice, it won't work anymore. If we'll try to test it, it will give us an error calling the invoke API action failed with the message rate exceeded. Let's change it back to 1 and save. As you can see, there's also a throttle button right here. All this button does is sets the value of the concurrency to 0. Effectively, it disables the function temporarily until we change the concurrency value back to a positive number. So in case of an emergency, if you quickly want to disable your function without deleting it, you can always hit throttle, confirm, and then this function is disabled and it is no longer servicing requests. One thing to keep in mind is that the concurrency value affects pricing because we pay for Lambda by the amount of executions and the execution time. So if we have a lot of processes running simultaneously, then we'll obviously have to pay for all of these executions. Let's set it back to unreserved account concurrency. And let's look at the next setting, which is the basic settings for a function, a memory and timeout. The first one is the memory, and this is how easy it is to configure the memory for our Lambda function. We can choose how much memory we want our Lambda function to have, and obviously the more memory we allocate for it, the more powerful and faster it will be. However, it will also cost more. If you click on this info link, you can see more information about the different pricing options and how much you will be charged for every execution depending on the amount of memory you chose. And here you can also configure a timeout. The value we set for the timeout determines how long would we like to allow our Lambda function to execute every request. If we set the setting to 3 seconds and we get a request that lasts longer than 3 seconds, this request will automatically be terminated after 3 seconds. And by the way, all of the active callbacks of this request will be terminated as well. If we'll increase this value, we'll allow our function to execute requests for a longer period of time. But just keep in mind that the duration of the function execution is one of the metrics that determines how much we'll pay for our function. So the higher we set this timeout value for, the higher potentially we will have to pay for executions. The next thing we'll look at are versions and aliases. Let's say we deploy version A of our function. Now we'll save it and test it. And now we can create the first version of our function. This works very similar to the way we would create a version for a library. We'll create version number 1, and then this version will be kept in memory, and we can always reference this version, even if we'll create later versions as well. The first version will always stay the same. So we'll go to Actions, Publish New Version, hit Publish, and we created the first version of our function. As you can see, now we can no longer edit this function. We get this message, code and handler editing is only available for the latest version. And we have the option to go to latest. So now we are viewing some sort of a sub-view of our function only for version number 1. And the code here is no longer editable. If we'll deploy version 2 and 3 and 4, we will still be able to reference this first version and execute it, and it will always work with this code that we already uploaded. So let's go back to our latest version. Now let's change it to version B, save, test, and let's deploy version number 2. And again, this version is now stored. Every time we'll execute version 2, we will get version B, and every time we'll execute version 1, we will get version A. Again, let's go back to the latest, and under qualifiers, versions, we see that we have version 1 and 2, and we can still reference them and go back to every version that we created before. So if we'll go to version 1, we will still see version A in the code of this version. So let's get back to the latest and create the last version C. Save. Okay, so now we have 3 versions, and now let's look at aliases. An alias is sort of a pointer to a version. We can create a production alias, and every time we will call this alias, it will point to one of the versions. And we can always change which version it points to. So let's try to do that. We'll create a new alias. We'll call it production. And let's point it to version number 2. Now our alias was created and it points to version number 2. If we'll go back to the latest, we will see under qualifiers that we have this production alias. It points to version number 2. And if you look at versions, we'll see that version number 2 has this alias production. So what does that mean? If we'll go to our production alias and we'll execute our test event, you can see that we got version B as a response. But we can always change which version this alias points to. If we'll change it to version number 1 and execute it, we will get the response we would expect from version number 1, which is version A. So an alias is a pointer to any of the versions we have under our account. And that's very convenient. For example, if you have a production environment, we can deploy many new versions in the background without pointing the production environment to them. We can create another alias for a QA environment, point it to the latest version, and once we're satisfied with it, we can point our production alias to the latest version. So let's try it out. Let's point our production to the second version. Let's say that this is the latest stable version. And let's also create a QA alias. We'll call it QA and we'll point it to the latest version number 3. Now that we have the QA alias created, we can test it. We can see that we have version C, which is the 3rd version being executed. So now under qualifiers, we have the QA alias that points to the 3rd version, and we have the production alias that points to the 2nd version. To better illustrate how aliases work, let's create an HTTP endpoint and use it to point to our production alias. And for that, we can make use of triggers. Under this designer section, we have an option to add a trigger that will trigger our Lambda function. But first, we need to make sure that we go to our production environment, because we want to create our trigger for the production alias. Once we are in the production alias, we will go to the designer and add a trigger. And in here, we have the option to choose one of the AWS services that can trigger our Lambda function. We can choose S3 that will trigger our Lambda function when there's a change on our S3 bucket. We can configure our function to listen to the SQS queue or changes in DynamoDB or many other AWS services, or we can even choose outside event sources that will trigger our function. But we'll use API gateway because we want to get an HTTP endpoint. We'll choose to create a new API and we'll make it open. Now that our trigger was created, we get this API endpoint. And when we call it, we get version B because it uses our production alias, and our production alias points to version B, which is version 2. If we'll go to qualifiers, production alias, we can always change the version the production alias points to. So if we'll change it to version number 3 and save, now if we'll refresh our API endpoint, we'll get version C in here. And that's just how easy it is to do a deployment and switch the version that our alias points to. So for example, in a real production environment, let's say we deploy a new version. We can first point the QA alias to this version and use the QA endpoint to test it. And then once we know it's ready, we can easily point our production alias to this version, and it immediately is available for all of our users that use the production alias. And then let's say we find out there's a bug with our third version. We start seeing some errors in our error log, and we realize that we did something wrong and we want to quickly roll back to the second version. All we need to do for that is go back to the console, choose version number 2, save, and then all of our users automatically will get the second version. This makes deployment so much easier than provisioning servers while our server is starting and our code builds and all the dependencies are installed. And then if we want to roll back, it also takes time because we need to build the previous version. With Lambda, it just takes a few seconds. We deploy a new version and then we can always switch which version the alias points to. So that's one of the other major advantages of a Lambda function. This concludes this introduction video for AWS Lambda. We covered basic configuration options and explained a few terms and how the Lambda function works. If you have any questions or ideas for future videos or something else you would like to see, please leave a comment in the comment section below. If you learned something from this video, please like it. Also, if you would like to get notified when I upload other videos, and I plan to upload more introduction videos for AWS services, you can subscribe to this channel.